Welcome to a new test and teardown video. This time it's another FLUKE multimeter, but this time it's an 8600A digital multimeter. So it's a little bit more advanced. It is now a 4.5 digit, and we got a few more features in this one. For example, auto range. So that is super cool. They also use two different grounds for volt and ohm and for current. So I think this is a good way to make it more accurate. This one is a little bit special, and here is something that you need to check every time you play around with FLUKE multimeters like this. It is the options. This one is made for 250 volt. All that is perfectly fine. 230 is here, but it can of course do up to 250, right? And look at that. Battery, right? Charging batteries. I think this one is the battery one. Here we go. This one is the battery option. You see? And yes, there is a mark in that one. And I must say this unit is very, very heavy. So I expect there will be a lot of leaked batteries. It's also a little bit open here, and we got a little bit of a crack in the handle. Where is that? See, here we got a crack. So we need to be careful not to put it, see? Not to use the handle as a stand. So I need to open this one first, and let's have a look. I must say I'm a little bit depressed about yesterday's FLUKE multimeter, so I hope this one is gonna be better. It looks like the contacts are good. Oh, this one is funny. So now we're inside the FLUKE 8600, and it looks like the basic idea is more or less the same like the 8000. Again, they're using this thin flexible PCB, and it is directly soldered into the main board. So that is definitely a very, very good idea. I totally like that one. And the switch sections looks the same. The sense resistors look the same. We got a little bit different modules here, and all that kind of stuff is different. There's a lot more electronics inside this unit. And yes, of course, we got rechargeable batteries. I think those are nickel cadmium or nickel, yes, cadmium, nickel cadmium, yeah. So I definitely need to remove those because we don't want any leaking cells in our units. But it looks like it's not that bad with leakage here. So we got a little bit of funny repairs done to this unit. For example, look at that IC. Ooh, that is gross. I'm not super impressed about that repair. We got a little bit of relays. Also some signal relays there. Oh, look at the implementation of that relay. Well, that is cute. And then the way that they soldered this IC, I mean, I'm not impressed. This is not so beautiful. We also got a little bit of funny modifications here. I am not super happy so far. But I have to remove the batteries first. Those are actually quite smart, those battery holders here. So we got a piece of flexible material here, and then it's hold together with these, and then you screw them together like that, so it's is really nice and stable. I see a little bit of corrosion and stuff on that one. But other than that, I think I'm very, very lucky today with this one. Especially if you look at the cells. I don't know if you can see this. But I think we have a corrosion underneath here. And they all look like this. So I think it was in the last minute. Is this a date code or something? I don't know what that means. Well, anyway, let's try and power this up. So let's try the first power on. I will turn on mains voltage, and I do expect a little bit, and that is 0.9 watts. That is, of course, the transformer is running, because it's normally the way that it's made. It's designed to charge the batteries in power off mode. So that was expected, perfectly fine. Yes, this is exactly a known problem with the power supply, and I need to go and fix this. I totally expected this to happen. Alright, so here's what I did first. Of course, the 4 cells, they're in series, so it's quite easy to see how it's connected. And here's a wire that goes to that one. So that means that will be the end of the series connection, positive and negative. And since we've got 4 cells, that means, okay, we should be able to run on 5 volts, right? So now I've got 5 volt input from a power supply, and look at that. The unit is definitely up and running. And the current consumption is 0.5 amp. It depends a little bit. See, that is auto level. I don't know. This is resistance. I think it's because we got some relays in here, and of course they take a little bit of power. But anyway, it's definitely online. So all I have to do now is create a 5 volt supply. Easy, easy. I am going for a little bit of a different approach, as you can see. I removed all the stuff that I don't need. And here is what I want to add. A little switch mode power supply, 5 volts, 2 amps. But I need only 0.5 amp, so that should be perfectly fine. I think I'll be able to fit it somewhere in here, right? So that was not too bad. Yeah. Look at all those different mounting holes I could have used. But this particular power supply board, there was just no mounting screws in anyway, so what I did here is I just took some thick copper wires, and now it's actually really, really nice and stable, and it fits, as you can see here. It will be all right. So let's power it up and see if it works. Definitely a lot less weight. So let's try and see. Here we go, and of course it is alive. I left this cute blue LED in there just for fun. And the power consumption is 5 watts. And here is 5 volt input, and it is super nice and accurate. What a good day. I was a little bit afraid of the different ranges, but that seems to be okay, because all those really, really ugly repairs that somebody did, that I think all those resistors and this, the resistors here and transistors and all that kind of stuff, that got to be range stuff. But that seems to be good. I will of course try the fine range, that is the 2 volts, so give it 1. And let's go down to that one. Oi, now we got digits. And that is alright too. What a lucky day. Happy. Oh, you gotta see something. Sorry about the sun is shining in here. Let me see if I can be here. So the input impedance. Look at that. Then I go back to 2 volt. And then I come with my 1.2345. And then I remove it. Oh, I'm a little bit impressed. So there isn't anything that discharges the unit. It will just stay like that forever. That is a little bit funny. I mean, that can't be a feature. So maybe there is a resistor missing to ground, but it measures absolutely accurate. What do you think about that? Anyway, there's not a lot more to say about this absolutely fantastic FLUKE 8600. So thank you very much for watching and have a good day. Bye.